Kn cross curve of stability. Kn cross curves are constructed for an assumed kg of 0. That means G at the moment while constructing the Kn cross curves of stability is considered to be at the keel of the vessel. Kg, that means Kg becomes 0. Kn is nothing. Kn is just a lever which is purely derived on hull form. We can also call it, like, considering the geometrical shape of the vessel, it is obtained by the naval architects while the vessel is being built. Why do we need Kn? Why do we need Kn? What is the need to get or use Kn? The Kn is used to determine Gz. Kn always remains constant for any particular angle of heel. It is always constant for a particular angle of heel. If we know the Kn, the Kg can always be determined by the officers on board. We know the Kn given to us by the naval architect, the Kg derived by the officers while on board, and both of these factors, they will give us the figure for Gz. The importance of Gz, we all know it. Now let's consider this diagram in which the vessel was originally floating at stable and floating at waterline. This was the initial. Vessel was heeled to an angle theta, and now the waterline shifted to WL1. Okay. Now, when the vessel was floating at normal this equilibrium, at the same time, vessel was having also a center of buoyancy initially. For sure, if it is floating in the water, it needs to have a center of buoyancy. When the vessel got heeled to an angle theta, this center of buoyancy shifted to B1. It got shifted to B1. Force of buoyancy is acting upwards. Now, if we extend this line downwards and we connect this force of buoyancy line, which was going upwards, and from the keel, we join them horizontally, this will cut somewhere known as, we name this point N for our sake. This is our Kn. Where it will be required? It will be required in the future. Now let's take, this is our, take another color, let's take blue, green. Okay. Now the Kn has been determined by the naval architect by using his mathematics and physics, everything. They have given us the Kn for each and every angle of heel, and it has been mentioned in the stability booklet. Vessel comes into service, the vessel is loaded, and in this particular loading condition, the G is somewhere over here. Now vessel is heeled to that same angle theta, and when angle theta, this G connects to the force of buoyancy. At that particular angle theta, we had already know that B will be at B1. The line going upwards from B1, G is connected with that one, and this gives our Gz, which we call as righting lever. We know that G is the force of gravity which will be acting downwards, right? Gravity force acting downwards. We already know Kn. Yes, we know. We need to find out Gz. Okay, right. We know whatever the Gz is, the Gz is somewhere also equal to this line. Let's name this point X. So we know that gz will be equal to xn. Okay, fine. We also know that this angle theta, which is coming over here, this angle theta is also equal to this angle theta 1, call it theta dash. Okay, let's consider a triangle. Which triangle? We'll consider the triangle KXG. KXG. We already know this thing. On board it has been calculated. What things do we know in this triangle KXG? KG we have, easy peasy, calculated already on board. Theta we have, we know what is the angle of heel. What we do not know, we do not know what is this KX. Over here we have already established that this GZ and this XN both are similar. Same, GZ equal to XN. To find out XN, if we can, KN which we already have, subtract what? KX. This will give us XN, which is also similar to GZ, right? We need to find this thing. So in triangle, this thing, what? Sine theta. Sine theta equal to perpendicular upon hypotenuse. This is the perpendicular KX, which we need to find out. So sine theta equal to KX upon KG. KX equal to KG sine theta. That means this over here we can also say Kn minus Kg sine theta equal to Xn, or Xn is also equal to Xn अपन को मिल गया. We found out what is now Xn. This Xn is equal to GZ. GZ equal to Kn minus Kg sine theta. This is where the formula comes from, and this is what or why Kn is necessary. This is why Kn is necessary. Thank you.